Hello everyone, this is Mix K. Today I'm going to be making a little video going over the first page of notes. So if you look at this first page of notes, we are looking at polarity. So we talked a little bit about polarity in our previous units, but I just want to remind you of a couple things. So we have polar and nonpolar. Polar shares electrons unequally. So two atoms are fighting over those electrons, and their difference in electronegativity is bigger, 0.5 to 1.6. Now remember, electronegativity is how well an atom attracts electrons. Okay, atoms attract electrons. So if it has a big electronegativity, it's very good at attracting electrons. And if it has a low electronegativity, it's very bad. So we can kind of think about this as strength and kind of like a tug of war. Now the other thing we have to think about is that the electrons are being pulled in the same direction. So for this example, we're going to look at hydrochloric acid. And hydrochloric acid has a dipole. And so what is a dipole? It is a separation of charges. A separation of charges. So if we look, this penguin here is going to represent a weak atom, one that has a very low electronegativity. He is not good at attracting electrons. We can tell because he's smaller, he's a little weaker. Here, chlorine is represented by a polar bear. He has a really high electronegativity. He's really good at attracting electrons. And this ice cream cone is going to represent our bond with these two scoops of ice cream representing our electrons. So we can see when an atom has a stronger electronegativity, it is better at attracting electrons. Just like a polar bear is stronger than a penguin and can pull the ice cream cone closer to it. So right now you can look, are they sharing this ice cream equally? No, the polar bear is attracting it more. So are these two atoms attracting the electrons equally? No, the chlorine is pulling them over to one side. Now what does this mean? That means our chlorine is going to be a little bit negative and our hydrogen is going to be a little bit positive. And if we remember, positives and negatives attract. Now, if we look at H2O, we have two hydrogens and an oxygen. H2O has two dipoles because it's bent shape. It also has a dipole in the sense of an overall polarity. So here we can look that this polar bear is much stronger than the two penguins, and he's pulling the ice cream cones away from them. He is hogging those ice cream cones. But the penguins are still holding on, so they're technically still sharing. But this polar bear is attracting them more. So if we think about this in terms of atoms, the O is stronger. It is pulling the electrons away from the hydrogen. This means our O is a little bit negative and our hydrogens are a little bit positive. So it's like he's winning the tug of war against two different teams. And he's way stronger and pulling the electrons in the same direction. He's pulling them all towards himself. Now, just because we have someone that's strong or weak doesn't mean it's always going to be polar. So nonpolar is when they share electrons equally. So if they share electrons equally, they have a smaller difference in electronegativity. So they're both just about as strong as each other. So if we look here, we have two ends, and they both have similar electronegativities. Or if they don't have similar electronegativities, they cancel each other out by pulling equally in all directions. So let's look at this first one. I have two nitrogen atoms, two polar bears, and they're sharing their electrons. There's more electrons here because we have a triple bond. But because they are both just as strong, neither of them is able to pull the electrons into one direction or the other, so they have to share them equally. Now, when they share them equally, there is no charge, no dipole. So now we don't have positive and negative charges to help us attract. In CO2, well, technically oxygen is stronger than carbon. But if we look, the oxygens are pulling in equal and opposite directions. So those pulls end up canceling out. So this carbon, he's stuck in the middle, and he's having the electrons pulled away from him. But because this side's pulling just as strong as this side, it ends up being a tie, and they do not move. So if we look, the electrons are right in the middle of our bond because the two oxygens are pulling just as strong. Okay? So polar, let me zoom out. Polar is when one is stronger than the other, and they pull the electrons in one direction. So we end up with a negative and a positive. A negative and a positive. In polar, they have equal electronegativities or very similar. So when they pull on those electrons, they pull it just as strong. Those strengths cancel out, and they have to share them equally. It doesn't matter if there's an atom stuck in the middle. If two atoms are the same and they're pulling in opposite directions, it's going to cancel out. Now, why do we care about this? Well, we know positives and negatives attract. So if, let's say, this oxygen on this water is also negative, well, that means we can form an attraction between the positive of one and the negative of the other. For nonpolar ones, it's a little more complicated. They are going to attract each other, but they're going to have very weak attractions because they do not have the positives and negatives holding them together. So if something has charges, it'll mix really well. And if something doesn't have charges, it will mix very well. But what doesn't mix well is when we have something with charges and something without. So we have a little phrase to help us with this. It's called like dissolves like. Okay. So a couple definitions to round us out. A solute is any substance that dissolves in the solvent. So this is the thing that does the dissolving. We add it to a liquid. Solvent is the substance that dissolves the solute. So this is usually water. Soluble means it does dissolve. Insoluble means it does not dissolve. So why do we care about polarity? Polar things like to dissolve in other polar things. Charged things like to dissolve in other charged things. Nonpolar substances like to mix or dissolve with other nonpolar substances. Okay, have an amazing day. Goodbye, everybody.